Welcome to The Explainer. Today, we're jumping right into a real cosmic detective story from the 8th grade curriculum called Celestial Impact: Meteors, Climate, and Divine Order. We're going to explore some massive scientific phenomena, look back at a few of the most dramatic days in Earth's history, and see how the source material connects all of this to a much larger design. So let's just dive right in. Okay, so what happens when the sky falls? I mean, it sounds like something straight out of a sci-fi blockbuster, right? But rocks falling from space? That is a very real, scientifically documented thing. We're not just talking about those tiny shooting stars that look so pretty on a summer night. We are talking about massive celestial bodies hurtling through the vacuum of space, literally on a direct collision course with our planet.
Just look at this number. Over 1,000. That's how many people were injured back in 2013 during the Chelyabinsk event in Russia. And here's the wild part. It was a relatively small asteroid, maybe the size of a 6-story building, that entered our atmosphere and just exploded in the sky. The shockwave was so incredibly powerful, it blew out windows across the entire city. Most of those 1,000+ injuries, just from shattered glass. It's a pretty intense reminder that these cosmic events aren't just ancient history, you know? They are a modern reality.
Which brings us to Chapter 1. Fire in the sky.
So when a piece of space debris enters Earth's atmosphere, it is moving fast. We're talking tens of thousands of miles per hour. The friction is so intense that the rock literally ignites, creating this terrifying yet kind of mesmerizing fireball. Now, a meteor impact is officially defined here as a massive release of kinetic energy caused when a large celestial body collides with Earth. Because you see, a meteor strike isn't just a big rock hitting the dirt. No, it is a colossal, violent release of energy. All the speed and mass of that space rock instantly converts into heat, light, and explosive force the absolute second it strikes. It fundamentally alters the landscape in a fraction of a second.
Moving right along to Chapter 2, How Meteors Change the Climate.
Now, you might be wondering how one localized strike can ripple out and completely change the weather of the entire planet. Well, the curriculum breaks down the scientific chain reaction like this. Step 1, you have that massive energy impact we just talked about. Step 2, that sheer force instantly vaporizes rock and throws millions of tons of dust, debris, and ash high up into the Earth's atmosphere. Step 3, all that material spreads out and essentially acts like a giant shield, blocking the sunlight from reaching the Earth's surface. The skies can turn dark for months, sometimes even years. And finally, Step 4, without sunlight, the Earth experiences this dramatic, rapid cooling. Plants can't photosynthesize, so they die. Herbivores lose their food source and, well, the carnivores follow right behind them. The whole global food chain gets completely disrupted by a sudden worldwide freeze.
That takes us to Chapter 3, History's Biggest Cosmic Impacts.
To give you a sense of the scale and frequency of these cosmic events, let's map out 3 defining impacts across history. Way back, 66 million years ago, we had the Chicxulub impact. The big one scientists believe contributed to the mass extinction of the dinosaurs. Fast forward to 1908, we've got the Tunguska explosion in Siberia. And then, super recently in 2013, the Chelyabinsk airburst. Seeing them all laid out like this really drives home the fact that Earth is just floating in a highly dynamic, constantly moving solar system. Let's actually compare 2 of those massive events side by side, because it perfectly illustrates the different ways these impacts work. On the one hand, you've got the Tunguska event of 1908. A meteor exploded in the sky with such crazy force that it flattened 800 square miles of trees in Siberia, smashed them flat like matchsticks. But amazingly, it left absolutely no crater. None. It was a pure airburst. On the other hand, we have Chicxulub from 66 million years ago. Now, this one made direct impact, leaving a massive crater in the Yucatan Peninsula, and triggering that global cooling and mass extinction we talked about. So the main takeaway here is that a celestial event can be devastatingly destructive, completely altering an environment, even if it never actually leaves a hole in the ground.
All right, Chapter 4, Watching the Heavens.
Now, don't panic. While it's true most space rocks are small and just burn up safely in our atmosphere as shooting stars, space agencies around the world are constantly tracking the skies. They monitor near-Earth asteroids using incredibly powerful telescopes and advanced satellites. They also meticulously analyze past impacts, like Chicxulub and Tunguska, just so we can be as prepared as possible. The ultimate goal, of course, is to identify threats long before they ever have the chance to strike. Which leads to a really critical question the curriculum poses. Is it wise to invest in asteroid defense systems? Why or why not? I mean, we've just seen the sheer power of these meteors and how quickly they can completely alter the climate.
Does it make sense for humanity to spend so many resources tracking these celestial objects? Thinking critically about this is really about understanding our survival, our preparation, and ultimately, our place in the universe.
And that brings us to Chapter 5, Divine Order and Stewardship.
At this point, the source material shifts gears a bit, moving from the mechanical science of the cosmos to a much more spiritual perspective. It quotes Genesis 1:16b, "He made the stars also." The curriculum uses this really short, simple sentence to present the idea that every single celestial body, from the smallest burning meteor to the most massive galaxy, was designed by God with incredible purpose and wisdom. From this viewpoint, the universe isn't just some random collection of dangerous rocks flying around. It's seen as a meticulously crafted system.
According to the text, Earth's delicate balance should actually remind us to stay in awe of this handiwork. The idea presented here is that understanding the massive cosmic risks that are out there, like the explosive power of meteors and the potential for those drastic climate shifts, well, it actually helps us appreciate how perfectly crafted the Earth is. The balance required to just support life here is incredibly fragile, and the source material suggests it is miraculously sustained against all odds.
Chapter 6, Knowledge Rooted in Morality.
So, a really foundational concept in this series is the idea that education without morality hurts. The curriculum argues that, hey, gathering scientific facts is fantastic, but scientific data, like knowing exactly how a meteor impacts the climate, is kind of incomplete without a moral compass to use that knowledge responsibly. The perspective here is pretty clear. Raw intelligence means nothing if it's used to make choices that hurt ourselves or the people around us. It requires moral stewardship to properly care for the Earth and our fellow human beings.
To back this up, the course draws on Romans 8:6-7, which promises peace of mind to everyone who keeps their mind spiritual. The lesson wraps up this section by concluding that intertwining biblical morality with education brings lasting peace of mind. It essentially presents the idea that having a spiritual mindset is the ultimate key to a truly successful, meaningful education. And here is a final provocative question the curriculum leaves us to ponder. How will you use your knowledge to steward God's creation? We've explored the awesome, terrifying power of the cosmos today and the incredibly fragile balance of our climate. The challenge presented by the source text is to take all this new scientific knowledge, pair it with moral wisdom, and really figure out how it can be used for good. Thanks for joining me on this explainer. Keep asking those great questions, and I'll catch you next time.